They mocked his farm boy engine fix until his Jeep outlasted every vehicle. The Jeep sat motionless in the motor pool. Private First Class John Henderson tightened the last bolt on the oil pan. July 25th, 1943, Sicily. His hands stopped. The engine he'd just rebuilt defied every specification in the technical manual TM 9-803. Every single rule. His breath caught. 30% more oil capacity than standard. 40% faster flow rate. The radiator modifications alone would make Captain Smith order a court-martial. Master Sergeant Michaels's voice still echoed from 2 weeks ago. Farm boy abortion. Henderson wiped his palms on his coveralls. The Mediterranean sun baked the motor pool at 113 degrees Fahrenheit. Standard Willys MB engines were failing everywhere. Overheating, seizing, dying in the Sicilian dust with their textbook perfect specifications. His engine would either prove him right or destroy his career. Both outcomes terrified him equally. 14 days earlier, Henderson had stood in the same motor pool, holding technical manual TM 9-803 like scripture. July 11th. Dawn. Temperature already at 95 degrees. The manual specified exactly 1.25 quarts of oil for the Willys MB engine. Exact viscosity. Exact grade. Exact everything. Henderson had memorized every word during his training at Fort Knox, 8 months ago, in a Kentucky winter that felt like a different universe. Private Henderson. Master Sergeant Michaels marched across the compound. 42 years old, 20 years in the Army. A man who believed regulations were written in the same tablets as the Ten Commandments. Henderson snapped to attention. Sir. The colonel's Jeep broke down again. Michaels thrust a requisition form at him. Third engine failure this month. Fix it. Buy the book. The exact book. Yes, sir. Henderson examined the colonel's Jeep. Engine block cracked from overheating. Oil turned to sludge. The engine had lasted exactly 72 hours before failure, standard for Sicily's conditions. But something nagged at Henderson's mind. He'd grown up on a 5,000-acre farm in Nebraska. Harsh winters, brutal summers, equipment that had to work or crops died. His father never cared about manufacturer specifications. He cared about one thing. Did the machine survive the season? Henderson's hands trembled slightly as he opened the hood. The Willys MB engine was designed for European combat. France, Belgium, moderate temperatures, occasional dust. The engineers at Willys Overland Motors in Toledo, Ohio, had built a magnificent machine for conditions that didn't exist in Sicily. Here, temperatures hit 115 degrees. Dust infiltrated everything. Fuel quality was inconsistent, sometimes American, sometimes captured Italian, sometimes improvised mixtures that barely qualified as gasoline. The textbook engine died in 72 hours. Henderson. Michaels appeared behind him. You going to stare at it or fix it? Sir, I was thinking. Thinking? Michaels' face reddened. I gave you an order, Private. Replace the engine. Standard specifications. Move. Henderson pulled himself back. Yes, sir. He spent the next 6 hours installing a replacement engine. Perfect installation. Perfect torque on every bolt. Perfect timing. When he finished, the engine purred exactly as technical manual TM 9-803 promised. It would die in 72 hours. That night, Henderson couldn't sleep. The tent was suffocating, 105 degrees even after sunset. Around him, 40 men snored and shifted on their cots. Outside, generators hummed. Somewhere in the distance, artillery practiced night firing. Henderson stared at the canvas roof. 5,000 acres. That's what his father managed with equipment that manufacturers said couldn't handle Nebraska conditions. International harvester tractors modified to run in 30 below winters. Trucks with cooling systems rebuilt for 100-degree summers. Engines that should have failed but ran for 20 years because his father understood one principle. Specifications were starting points, not ending points. "You awake, Henderson?" Corporal Davis whispered from the next cot. "Yeah. Can't sleep in this heat?" "Something like that." Davis rolled over. "You know what I heard? The British use different oil in Africa. Thicker. The Eighth Army figured it out in Egypt. But we're Americans. We follow the manual." Henderson sat up. "They use thicker oil?" "That's what I heard from a supply sergeant. The Brits learned the hard way in the desert. But good luck getting our brass to admit American engineers made a mistake." The conversation ended, but Henderson's mind accelerated. Thicker oil, more oil, better cooling. Everything his Nebraska instincts screamed was necessary. Everything the manual forbade. The next morning, Henderson reported to the motor pool at 0530. Master Sergeant Michaels was already there, inspecting the line of jeeps. "Henderson, the captain wants to see you." Henderson's stomach dropped. "Sir?" "Move, Private." Captain Richard Smith's office was a converted farmhouse 300 yards from the motor pool. Henderson knocked. "Enter." Captain Smith sat behind a desk made from an old door and 2 crates. 38 years old. West Point, class of 27. A man who'd memorized regulations before Henderson was born. "Private Henderson, Master Sergeant Michaels tells me you hesitated yesterday." "Sir, When given an order to fix an engine by the book, you hesitated. Stood there thinking. Is that correct?" "Yes, sir." Smith leaned forward. "In this Army, Private, we follow orders. We follow specifications. We follow the manual. Do you know why?" "Sir, because 50,000 engineers in Detroit spent 5 years designing these vehicles. They're smarter than you. They're smarter than me. They built these engines to survive European combat, and by God, that's what they'll do. Are we clear?" Henderson's jaw clenched. "Sir, with respect, the engines are failing every 72 hours in these conditions." "Dismissed, Private." "Sir, dismissed." Henderson saluted and left. Outside, the sun climbed toward its daily peak of 115 degrees. Across the motor pool, 3 jeeps sat with their hoods open. Failed engines. All perfectly maintained according to Technical Manual TM 9-803. All dead. Something broke inside Henderson at that moment. Not his discipline, not his respect for command. Something more fundamental. His willingness to watch machines die when he knew how to save them. He made a decision that would either end his military career or change how the U.S. Army maintained vehicles in extreme conditions. That afternoon, he requested a meeting with Master Sergeant Michaels. "What do you want, Henderson?" "Sir, I want to rebuild one engine. Experimental modifications. My own time, my own responsibility. If it fails, you can have me court-martialed. Michaels stared at him. You want to modify a U.S. Army vehicle? Yes, sir. Against specifications? To improve specifications, sir. Michaels's face went through several colors. You Nebraska farm boy piece of... You think you're smarter than Willys Overland? No, sir. I think Willys Overland never tested their engines at 115 degrees with dust and bad fuel. Get out of my sight before I have you digging latrines for the rest of this war. Henderson didn't move. Sir, give me 2 weeks. 1 engine. If it fails, I'll accept any punishment. If it succeeds, maybe we save some lives when these jeeps break down during combat operations. Michael's jaw worked. Silence stretched. 2 weeks, he finally said. Your own time, after regular duties. And Henderson, when this farm boy abortion of yours melts down, you'll wish you dug those latrines. Henderson started that night after evening formation. 2,200 hours. The motor pool was empty except for 1 damaged Jeep scheduled for parts salvage. Henderson signed it out for experimental mechanical evaluation. Vague enough to be technically accurate, specific enough to not be an outright lie. He pulled the engine using the motor pool's chain hoist, a process that normally required 2 men, but which he managed alone through careful leverage and patience. The engine swung free of its mounts at 2,300 hours. He lowered it onto a workbench under a single hanging bulb. 60 watts of harsh white light, creating sharp shadows in the otherwise dark motor pool. For 1 hour, he just looked at it. The Willys MB engine was beautiful in its way. 60 horsepower at 4,000 revolutions per minute. 134 cubic inches of displacement. Overhead valves. Cast iron block. 4 cylinders inline. 7 main bearings. Compression ratio of 6.48 to 1. Every specification memorized. Every tolerance understood. American engineering at its finest for moderate European conditions. But Henderson wasn't in moderate European conditions. He thought about his father's farm. 5,000 acres of corn and wheat in Nebraska. His earliest memory was standing in the equipment shed at age 5, watching his father and 2 hired men rebuild a tractor engine. International Harvester Model F20. The engine had died during spring planting, catastrophic timing that threatened to delay the entire season. His father had examined the failed engine and said, "Manual says this engine needs specific oil weight for Nebraska winters." But Manual was written in Chicago. They don't know Nebraska. The hired man, old Tom Peterson, had argued, "But Mr. Henderson, if we deviate from specifications, we void the warranty." His father had looked at Tom with an expression Henderson would remember for 20 years. "Tom, warranty doesn't plant my corn. This engine needs to survive 30 below winters and 100-degree summers. Chicago engineers never tested for that range. So we'll modify it to handle what's real, not what's in some manual." They'd spent 3 days on that engine. Larger oil pan, modified cooling passages, heavier valve springs rated for temperature extremes. When they finished, the tractor ran for 15 more years without major repairs, outlasting 3 newer tractors that followed manufacturer specifications exactly. "Reality doesn't negotiate with paperwork," his father had said. "Physics is physics. Heat is heat. Metal expands and contracts according to temperature, not according to what some manual says it should do. You modify equipment to survive the conditions it faces, not the conditions engineers assumed it would face." Now Henderson pulled out a notebook and began writing observations. Problem 1. Oil capacity insufficient for heat dissipation in extreme temperatures. Standard 1.25 quarts overheats and breaks down at sustained temps above 110 degrees. Solution: increase capacity 30% to 1.63 quarts. This provides larger thermal mass for heat absorption and more time for cooling during circulation. Problem 2. Oil flow rate too slow. By the time oil circulates through engine at high temps, it's already degraded. Solution: modify oil pump for 40% faster flow rate. Faster circulation means each molecule of oil spends less time absorbing heat before being cycled back to the pan for cooling. Problem 3. Cooling system inadequate. Radiator designed for 60-degree combat, not 115-degree sustained heat. Solution: increase radiator surface area 15%. Add custom baffle system to direct more air across coolant tubes. Reposition fan shroud for better airflow under load. Problem 4. Air filter clogs too quickly in dust. Standard filter designed for European soil, not Sicilian volcanic dust. Solution: larger filter housing with preliminary screening stage. Two-stage filtration extends service life by estimated 300%. On his father's farm, they had solved similar problems with tractors, larger oil pans for longer work cycles without maintenance stops, modified cooling systems for summer harvests when engines ran 14 hours straight in 100-degree heat, custom air filtration for grain dust during threshing season. The principles were identical. The consequences of failure were just higher. Here, a failed engine during combat could mean dead soldiers instead of a delayed harvest. Henderson spent the first week on the oil system. He fabricated a custom oil pan from salvaged sheet metal, material scavenged from a destroyed German truck. The sheet metal was thicker than standard American material, actually better suited for the high-stress application. He measured, cut, bent, and welded. Each seam had to be perfect. No leaks, no weak points. He worked slowly, carefully, checking measurements 3 times before making each cut. The new pan increased capacity from 1.25 quarts to 1.63 quarts, a 30% increase. He modified the oil pump by hand-cutting new gears with slightly different tooth profiles, increasing flow rate by 40%. The increased flow rate would ensure faster circulation and better cooling at high temperatures. Every evening, he worked from 2200 hours until 0200 hours. 4 hours of sleep, then up at 0600 for regular duties. His hands grew calloused from the tools. His eyes burned from welding flash. His back ached from bending over the workbench. But the engine slowly transformed under his hands, from a machine built for European warfare into something designed for Sicilian survival. Master Sergeant Michaels watched with barely concealed contempt. "How's your farm equipment coming, Henderson?" "Fine, sir. Can't wait to see it blow up." "Maybe you'll learn why we follow regulations instead of playing cowboy mechanic." "Yes, sir." Other mechanics gathered sometimes to watch. Corporal Davis, Private Morrison, Sergeant Williams. They didn't help. That would violate regulations. But they watched, curious about whether Henderson's gamble would succeed or destroy his career. "You really think this'll work?" Davis asked one night around midnight, when Henderson was welding reinforcement brackets for the modified oil pan. Henderson set down his welding torch and lifted his face shield. "On my father's farm, we had an International Harvester tractor that should have died 10 years before I was born. It was built in 1925, rated for moderate Midwest climate. By 1935, it should have been scrap metal. But my father modified the cooling system. Larger oil capacity, better filtration. That tractor was still running when I left for the Army in '42. 17 years past its design life. This ain't Nebraska. No, but heat is heat. Metal is metal. Physics doesn't care about paperwork or jurisdictions. A molecule of oil breaking down at 120 degrees in Sicily follows the same thermodynamic laws as a molecule of oil breaking down at 120 degrees in Nebraska. The Army manual assumes moderate temperatures. My father assumed reality. Reality wins every time. And if you're wrong? Henderson looked at his modified engine, half-finished, strange-looking, violating every standard specification. Then I'll have learned an expensive lesson about overconfidence. But I don't think I'm wrong. Davis studied him. You got that farm boy certainty, don't you? Like you just know this'll work. Not certainty, confidence. There's a difference. Certainty means you're sure. Confidence means you've done the work, checked your assumptions, and believe you've probably got it right. But you stay open to being wrong. You ready to be wrong? Henderson smiled grimly. I'm ready to find out either way. The second week, Henderson attacked the cooling system. He modified the radiator configuration, increasing surface area by 15%. He repositioned the fan shroud for better airflow. He added a custom baffle system to direct more air across the engine block. None of these modifications appeared in Technical Manual TM 9-803. All of them violated official specifications. Captain Smith inspected the motor pool on day 10. What's that, Sergeant Michaels? Private Henderson's experimental engine, sir. Smith walked over. Henderson snapped to attention. At ease, Private. Smith examined the engine. His face darkened. This looks nothing like specification. No, sir. You understand that operating non-standard equipment in a combat zone is a court-martial offense. Yes, sir. And you're doing it anyway? Henderson met his eyes. Sir, I'm trying to build an engine that won't die every 72 hours. Smith's jaw clenched. You have until day 14. Then this experiment ends, one way or another. He turned to Michaels. If this engine causes any damage or injury, it's your responsibility, Sergeant. Understood, sir. On day 13, Henderson completed the modifications. The engine sat on the workbench, gleaming under the work light. Every bolt torqued, every connection sealed, every measurement triple-checked. He walked around it slowly, examining his work from every angle. The modified oil pan gleamed dully, hand-fabricated from salvaged sheet metal, welded seams ground smooth, capacity increased to 1.63 quarts. The new oil pump sat where the standard pump had been, its gears cut to different ratios for 40% faster flow. The radiator showed his custom baffles, directing air in patterns that Willys engineers never considered. It looked wrong. The oil pan was too large, the cooling system too elaborate, the whole assembly too heavy by 12 pounds compared to standard specifications. The proportions were off, like looking at a familiar face with slightly altered features. Technical Manual TM 9-803 would have no category for this machine. On paper, it violated every rule. In Henderson's gut, he knew it would work. That night, he couldn't sleep again. Not from doubt this time, from anticipation. Tomorrow would prove whether Nebraska pragmatism could triumph over Ohio engineering, whether real-world testing could override theoretical specifications, whether a farm boy's instincts meant anything against the weight of official doctrine. Day 14, 0600 hours. The motor pool was empty except for a few early arriving mechanics. Henderson arrived with his toolbox and the salvaged Jeep. The engine installation took 2 hours, longer than standard because his modified components required careful positioning. Master Sergeant Michaels arrived at 0730, coffee cup in hand. He watched without speaking as Henderson tightened the final engine mount bolts. "Last chance to back out, farm boy," Michaels said quietly. "Tell the captain you changed your mind. Go back to fixing engines by the book. Nobody would fault you." Henderson set down his wrench. "Sir, I didn't spend 2 weeks building this to quit now. Your career might end today, or it might begin." Michaels studied him. "You really believe in this thing, don't you?" "Yes, sir, I do." "Then I hope you're right, for both our sakes." Captain Smith arrived at 0800 precisely. He walked straight to the Jeep, not acknowledging Henderson or Michaels. He circled the vehicle once, twice, examining, judging. "Sergeant Michaels, what am I looking at?" "Private Henderson's modified engine, sir. Ready for testing." "It looks non-standard." "Yes, sir. Significantly non-standard." Smith crouched down, peering at the modified oil pan. He traced the welded seams with one finger. "Hand fabricated?" "Yes, sir," Henderson said. "From salvaged metal. Increased capacity by 30%. Smith stood. "And the cooling system?" "Modified radiator configuration, sir. 15% more surface area. Custom fan shroud and baffle system for better airflow." "Oil pump?" "Increased flow rate by 40%, sir." Smith was quiet for a long moment. "Private Henderson, I'm going to be completely honest with you. This looks like something built in a farmyard workshop, not a U.S. Army motor pool." "Yes, sir. If this fails, it's going to fail spectacularly, and I'll have to explain to the colonel why I allowed unauthorized modifications to Army equipment." "I understand, sir, but—" Smith met his eyes. "If it succeeds, we might save a lot of good engines from dying in this heat. So let's find out which way this goes." "Well, Private, ready for your test?" "Yes, sir. Start it up." Henderson turned the ignition. The engine caught immediately. Smooth idle. No unusual sounds. Everything seemed normal. "Take it around the compound," Smith ordered. "Standard speed. Let's see if your farm boy engineering holds up." Henderson drove the Jeep in a wide circle around the motor pool. 5 minutes. 10 minutes. 15 minutes. The engine ran perfectly. Smooth, powerful, no signs of stress. He returned to the motor pool. "Sir, she's running fine." "That's standard operation, Private. Let's see how she handles stress." Smith turned to Michaels. "Sergeant, set up a full load test. Maximum RPM for 30 minutes. Michaels smiled grimly. "Yes, sir." They attached a dynamometer to the engine, a device that measured power output while creating maximum load. Standard engines could handle this test for 30 minutes before overheating became critical. It was the Army's standard reliability test. Henderson started the engine. Michaels set the load to maximum. "Watch your temperature gauge, farm boy," Michaels said. The engine roared. 65 horsepower at 4,500 revolutions per minute. The temperature gauge climbed. 170 degrees. 180 degrees. 190 degrees. Standard engines hit critical temperature at 205 degrees. 5 minutes passed. The modified engine held at 195 degrees. 10 minutes. Still 195 degrees. 15 minutes. 196 degrees. Henderson's palms sweated. The oil pressure gauge showed perfect readings, higher than standard due to his modified pump. The engine note remained smooth. No knocking. No irregularities. 20 minutes. 197 degrees. Michaels frowned. Temperature should be critical by now. 25 minutes. 198 degrees. Farm boy knows his cooling, Davis muttered. 30 minutes. Henderson shut down the engine. Final temperature? 199 degrees. Just below the 205-degree critical threshold. But then something happened. As the engine sat idling after the test, temperature suddenly spiked. 200 degrees, 205 degrees, 210 degrees. "Shut it down!" Michael shouted. Henderson killed the ignition. Steam hissed from somewhere in the cooling system. Captain Smith's face was stone. "Looks like your experiment failed, Private." Henderson's stomach dropped. He'd been so close. 30 minutes of perfect operation, then failure at the finish line. "Sir, That's enough, Private. Report to my office at 1400 hours. We'll discuss your future in this man's army." Smith walked away. Michaels leaned close. "I told you, farm boy. Your abortion failed. Now you're mine." Henderson stood there as the motor pool emptied for noon chow, alone with his failed engine and his shattered confidence. But then something his father once said echoed in his memory. First failure tells you what to fix. Second failure tells you to quit. Never quit on the first failure. Henderson opened the hood. He traced the cooling system, checking every connection, every hose, every seal. There, a crimped hose near the modified radiator outlet. The increased flow rate from his modifications had created pressure that the standard hose couldn't handle. Under sustained load, it had partially collapsed, restricting flow and causing the spike. A $5 hose had defeated his 2-week project. Henderson checked his watch. 12:15. His meeting with Captain Smith was at 1400 hours. 1 hour and 45 minutes from now. He ran to the supply tent. "I need a heavy-duty radiator hose, 3/4 inch, high-pressure rated." The supply sergeant looked dubious. "For what?" "Emergency repair on the colonel's Jeep." A white lie, but close enough to truth if you squinted. The sergeant found the hose. Henderson ran back to the motor pool. He had 1 hour and 20 minutes before his career ended. He replaced the hose. 20 minutes. He reconnected the cooling system. 15 minutes. He refilled coolant. 10 minutes. He had 35 minutes left. Henderson started the engine, connected the dynamometer, set maximum load. The engine roared. 5 minutes. Temperature held at 190 degrees. 10 minutes. 192 degrees. 20 minutes. 195 degrees. 30 minutes. 197 degrees. Henderson kept going. 35 minutes. 40 minutes. Temperature stable at 198 degrees. At 13:55, 5 minutes before his meeting with Captain Smith, Henderson shut down the engine. No spike. Temperature slowly decreased as the engine cooled. Perfect operation. He grabbed his notes and ran to Captain Smith's office. Smith looked up when Henderson entered. "You're early, Private." "Sir, I found the problem. A failed hose. I replaced it and ran another test. 40 minutes at full load. Engine never exceeded 198 degrees. Henderson. Sir, please come see for yourself. The engine works. I know it works. Something in Henderson's voice made Smith stand. Show me. They walked to the motor pool. Michaels was there, probably expecting to watch Henderson's official dressing down. Sergeant, get that dynamometer hooked up again, Smith ordered. Sir? Private Henderson claims his engine works. Let's verify that claim. And Sergeant, this time we run it for 1 hour. Not 30 minutes, 1 full hour. Michaels paled slightly. Sir, that's above standard test duration. I'm aware. Connect it. Henderson started the engine. Smith checked his watch. 1 hour, Private. Beginning now. What followed was the longest hour of Henderson's life. The engine ran. Smooth. Powerful. Temperature crept up to 195 degrees and held. Oil pressure stayed perfect. No unusual sounds. No smoke. No failures. A crowd gathered. Every mechanic in the battalion eventually showed up to watch. Word spread. Henderson's Farm Boy engine was running an hour-long full-load test. At 30 minutes, Master Sergeant Michaels checked the temperature gauge. 196 degrees. At 40 minutes, he checked again. Still 196 degrees. At 50 minutes, 197 degrees. At 59 minutes, Captain Smith stood next to Henderson. Neither man spoke. The engine roared steadily. 60 minutes. Smith checked his watch and nodded. Shut it down, Private. Henderson cut the ignition. The engine spooled down smoothly. Final temperature, 198 degrees. As it cooled, no spike. No failure. Just a gradual, controlled temperature decrease. Smith stood silent for a long moment. Then he turned to Michaels. Sergeant, I want a full technical report on Private Henderson's modifications. By tomorrow morning. Sir? You heard me. Document every change he made. Every measurement. Every specification. If this engine performs in field conditions the way it performed here, we might need to implement these modifications across the battalion. Michael's jaw dropped. Sir, these modifications violate technical manual. The manual was written in Ohio for European combat. We're in Sicily with different conditions. If Private Henderson found a solution, I want it documented and tested. Smith turned to Henderson. Good work, Private, but don't celebrate yet. Tomorrow we test this in real conditions. If it fails in the field, all this means nothing. Yes, sir. After Smith left, Michaels grabbed Henderson's shoulder. Don't think this is over, farm boy. Field test is where real engines die. But Davis clapped Henderson on the back. You crazy son of a gun. You actually did it. Henderson didn't answer. He stared at his engine, his farm boy abortion, sitting innocently in its Jeep, having just survived a test that killed most standard engines. Tomorrow would tell if Michaels or Davis was right. July 25th, 0530 hours. The battalion prepared for a 119-mile road march from their current position near Licata to a new staging area near Palermo. Standard duration, 13 hours at an average speed of 9 miles per hour. Temperature forecast, 113 degrees by noon. 45 vehicles, 44 with standard engines, 1 with Henderson's modifications. Captain Smith briefed the convoy commanders. This is a logistics movement, not a combat operation. But we move through disputed territory, so stay alert. Standard maintenance protocols. Check engines every 2 hours. If any vehicle can't maintain pace, it drops out and waits for recovery. We can't slow the whole convoy for individual breakdowns. He paused and looked directly at Henderson, who stood with the motor pool crew. Private Henderson's modified Jeep will run in the middle of the convoy. I want constant monitoring of its performance compared to standard vehicles. Master Sergeant Michaels, assign someone to ride with Henderson and log data every 15 minutes. Yes, sir. Michaels turned to Henderson with a tight smile. Davis, you're Henderson's observer. Write down everything. When this farm equipment fails, I want documentation. Davis grabbed his notebook. Yes, Sergeant. At 0600, the convoy rolled out. Henderson drove with Davis in the passenger seat, documenting everything. Engine temperature, oil pressure, RPM, speed, ambient temperature, road conditions. The morning started cool by Sicilian standards, 82 degrees. The convoy moved in a long line along dusty coastal roads, 45 vehicles spaced 50 yards apart. The lead elements were reconnaissance jeeps, followed by supply trucks, then more jeeps, then the command vehicles. Henderson's modified Jeep ran in position 23, middle of the pack, where Michaels could easily monitor its performance against surrounding standard vehicles. First hour, perfect operation. The road was relatively flat, winding through fields of dried grass and olive groves. Henderson's engine matched the standard Jeeps in every way. Temperature held at 185 degrees. Warm, but well within acceptable range. Around them, 44 other engines hummed identically. The rhythmic sound of internal combustion filled the air, pistons firing, valves opening, exhaust pipes chattering. It was almost peaceful, this mechanical symphony rolling across ancient Sicilian countryside. Davis checked his watch at exactly 0700. First hour complete. Your temp is 185 degrees. Standard vehicles around us are reading. He craned his neck to see the gauge in the Jeep ahead of them. 186 degrees. Basically identical. As expected, Henderson said. The real test comes when ambient temperature rises and we hit the hills. How confident are you? Henderson considered the question. On a farm, when you modify equipment, you test it in real conditions before harvest season. No choice. It either works or your family doesn't eat that winter. This, he patted the dashboard, this tested perfectly in the motor pool. But that was stationary load. Now we'll see if it handles sustained operation with variable loads, changing grades and rising temperature. That's not an answer. 80% confident, Henderson said. The 20% that worries me is what I don't know. Second hour. Ambient temperature climbed to 102 degrees. The sun climbed higher, burning off the morning haze. Heat radiated from the packed dirt road in visible waves. Standard engines began showing strain. Temperature gauges across the convoy edged toward 195 degrees. Henderson could see it in the Jeep ahead, the driver glancing nervously at his temperature gauge, probably hoping it wouldn't climb into the red zone. Henderson's engine held at 188 degrees. Davis wrote in his notebook, Henderson's temp 10 degrees below average of surrounding vehicles. Oil pressure steady at 45 psi, higher than standard due to modified pump. No unusual sounds or vibrations. Engine note remains consistent. The convoy reached its first major ascent, a long grade climbing into foothills. This was where engines worked hardest, where temperature management became critical. Every vehicle downshifted. Engine RPMs increased. Load multiplied. Henderson watched his temperature gauge. 188 degrees. 190 degrees. 192 degrees. It climbed smoothly, predictably, without the sharp spikes that indicated cooling problems. The Jeep ahead of them, standard engine, showed 200 degrees and climbing. Your modified cooling system is working, Davis said, scribbling notes. Question is whether it'll hold when temperature really peaks. At the 2-hour maintenance stop, Michaels walked down the line inspecting engines. Standard procedure. Pop each hood, check fluid levels, look for problems. He started at the front of the convoy and worked backward, spending 30 seconds at each vehicle. When he reached Henderson's Jeep, he spent 5 minutes. He checked the oil, pulled the dipstick, examined the color and consistency, smelled it for signs of overheating or fuel contamination. He checked the coolant, removed the radiator cap carefully, still hot, looked at fluid level and color. He felt the engine block temperature with his hand, comparing it mentally to the dozens of standard engines he'd just inspected. Finally, he checked the temperature gauge reading and compared it to his own observations. "Temperature's lower than the others," he said. "Yes, sir," Henderson replied. "Significantly lower. 10 degrees at least." "About that, sir. Oil's cleaner, too." Michaels replaced the dipstick. Standard engines are already showing thermal stress in the oil. Yours still looks fresh. "Better circulation, sir. Faster flow rate means less time at high temperature. Oil spends more time in the pan cooling down, less time absorbing heat from engine components." Michaels slammed the hood. "Let's see if it lasts." But Henderson noticed something in Michaels' expression. A flicker of something that wasn't quite skepticism anymore. Maybe curiosity. Maybe the first hint of belief. 3rd hour, temperature hit 108 degrees. They climbed deeper into hills, steeper grades, heavier loads on engines. The landscape changed from coastal plains to rugged terrain, switchback roads, hairpin turns, constant gear changes that stressed transmissions and engines alike. Standard Jeeps began running hot. Temperature gauges showed 200 degrees, 205 degrees. Warning lights flickered on several vehicles, red indicator lamps that meant stop soon or destroy your engine. Henderson's gauge read 192 degrees. Davis stopped taking notes every 15 minutes. Now he was writing continuously, documenting the growing divergence between Henderson's engine and the standard engines surrounding them. "This is remarkable," Davis muttered. "Your engine isn't even trying. It's like watching a marathon runner breathing easy while everyone else is gasping." "It's designed for these conditions," Henderson replied. "Standard engines weren't." But inside, Henderson felt something building. Not quite triumph, not yet relief, but a growing certainty that his intuitions had been correct. Nebraska had taught him about machines in harsh conditions. The Army had taught him about regulations and specifications. Sicily was teaching him that sometimes reality sided with instinct over paperwork. 4th hour, the first breakdown. A Jeep from the supply platoon, overheated engine, cracked block. It pulled over. The convoy continued. 5th hour, 2 more breakdowns, both overheating. Both standard engines pushed beyond their design limits by sustained high temperature and heavy loads. Davis stopped writing observations and just stared at Henderson's gauge. 195 degrees and holding. "Your engine isn't even trying," Davis said. "It's designed for these conditions," Henderson replied. "Standard engines weren't." 6th hour, noon. Temperature peaked at 113 degrees. The convoy crawled through foothills, constant grades, constant strain. Engines screamed. 4 more vehicles dropped out. 8 total breakdowns. 18% failure rate among standard engines. Henderson's engine, 198 degrees, running smooth. 7th hour. Master Sergeant Michaels drove up alongside Henderson's Jeep in his command vehicle. He gestured for Henderson to pull over at the next maintenance stop. The convoy halted. Michaels walked straight to Henderson's Jeep. His face was unreadable. "Pop the hood." Henderson did. Michaels inspected the engine, checked oil color. Still clean amber, not the black sludge appearing in standard engines. Checked coolant, clear, not the rust-tinged brown of overheating systems. Felt the engine block temperature with his hand. "It's barely warm," Michaels said quietly. "Yes, sir." Michaels looked at Henderson. Something shifted behind his eyes. Maybe respect, maybe resentment, maybe just exhaustion from watching 8 good engines die. "Captain Smith wants a mid-March assessment. I'm telling him your engine is running 20 degrees cooler than standard under identical load." "Thank you, sir." "Don't thank me, farm boy. We've got 6 more hours. Plenty of time for your abortion to fail." But there was less conviction in his voice than before. 8th through 10th hours, grinding endurance. Temperature stayed at 111 degrees. The convoy pushed through endless Sicilian hills, upgrades that taxed engines, downgrades that tested brakes, around switchbacks that required constant gear changes. 4 more standard engines failed. Total, 12 breakdowns out of 44 standard vehicles. 27% failure rate. Henderson's engine, temperature varied between 196 and 200 degrees. Never exceeded the 205-degree critical threshold. Oil pressure stayed perfect. No unusual sounds. No smoke. No warnings. At the 10th hour maintenance stop, Captain Smith walked the entire convoy inspecting every remaining vehicle. He reached Henderson's Jeep last. "Report, Private." Davis handed over his notebook. "Sir, detailed logs for the entire march. Henderson's engine is running consistently 20 degrees cooler than surrounding vehicles. Oil quality remains excellent. No signs of stress or degradation." Smith read through the notes. His jaw worked. "Sergeant Michaels, how many standard engines have we lost?" 12, sir. All overheating-related failures." "And Private Henderson's modified engine?" "0 problems, sir." Smith closed the notebook. "Private Henderson, after we reach Palermo, I want complete documentation of your modifications. Every change you made, every measurement, every specification." He paused. "I'm recommending your design for battalion-wide implementation." Henderson's breath stopped. "Sir?" "You heard me, Private. If we can reduce failure rates by modifying our engines for these conditions, we have a responsibility to do so." "Good work." "Thank you, sir." Smith walked away. Michaels stood there, arms crossed, staring at Henderson's engine. "Farm boy," he finally said, "you might actually know what you're doing." The final 3 hours of the march were anticlimactic. 2 more standard engines failed. Total of 14 out of 44, a 32% failure rate. Henderson's engine ran without incident. When they reached Palermo at 1900 hours, Henderson's gauge read 201 degrees, slightly elevated from the sustained 13-hour operation, but nowhere near critical. That night, Master Sergeant Michaels called Henderson to the motor pool office. "Private Henderson, Captain Smith ordered me to compile a technical report on your modifications. I need you to document everything you did to that engine." "Yes, sir." "And Henderson," Michaels paused, "I was wrong about calling your work a farm boy abortion, about assuming you were wrong just because you didn't follow the manual. Your engine performed better than any standard engine in this battalion. That deserves recognition." Henderson didn't know what to say. "Don't get soft on me, Private. You still need to document these changes so we can implement them." "But Michaels extended his hand. Good work. Henderson shook it. Over the next 3 days, Henderson wrote detailed documentation of every modification. The 30% oil capacity increase, the 40% flow rate improvement, the 15% radiator surface area expansion, the modified fan shroud, the repositioned air filter. Captain Smith forwarded the documentation to Battalion Engineering. 2 weeks later, orders came down. Implement Henderson's modifications across all battalion vehicles operating in extreme temperature conditions. Master Sergeant Michaels supervised the conversion process. 20 mechanics working simultaneously. 240 engines modified over 4 weeks. Henderson trained them personally on each modification. The farm boy private became the expert. Men twice his age asked his advice. Officers consulted his notes. The results were undeniable. Engine failure rates dropped from 32% to 6%. Vehicles lasted 4 times longer between major overhauls. Maintenance hours decreased 40%. The battalion's operational readiness jumped 20 percentage points. 3 months later, Captain Smith called Henderson to his office again. Private First Class Henderson, I'm pleased to inform you that your modifications have been reviewed by Army engineering staff. They are recommending your designs for implementation across all vehicles operating in Mediterranean and North African theaters. Sir, I don't know what to say. Say you'll accept this. Smith handed him a promotion warrant. You're now Sergeant Henderson, and you're being transferred to Battalion Engineering staff as our specialist in extreme environment vehicle modifications. Henderson stared at the warrant. Sergeant stripes. 6 months of service. A Nebraska farm boy who'd defied regulations and somehow ended up changing how the U.S. Army maintained vehicles in combat. Thank you, sir. Thank yourself, Sergeant. You saw a problem, found a solution, and had the courage to push forward despite resistance. That's what this Army needs. And if you found this story as powerful as I did, show your support by hitting that like button. It helps share these hidden histories with more people who need to hear them. 6 months after the Sicily convoy, Army engineers from Detroit visited the battalion. They disassembled Henderson's original modified engine, the one that had run through the 13-hour march, and examined every component. Senior Engineer Thomas compiled the report. After approximately 600 hours of operation, twice the standard overhaul interval of 300 hours, Henderson's modified engine shows 55% less bearing wear compared to standard engines after 300 hours. Piston ring wear is 42% lower. Valve train components show minimal degradation. Most remarkably, oil analysis reveals significantly less thermal breakdown products, indicating his enhanced circulation and capacity modifications successfully manage heat stress in extreme temperature environments. The report concluded, Private Henderson's modifications represent a fundamental rethinking of engine requirements for non-temperate combat theaters. His approach, prioritizing sustained operation in harsh conditions over ideal condition performance specifications, should inform future military vehicle design. Recommend immediate implementation of Henderson cooling and lubrication enhancements for all vehicles deployed to Mediterranean, North African, and Pacific theaters. By war's end, over 15,000 U.S. Army vehicles had been modified using Henderson's designs. Post-war analysis showed these modifications reduced engine failure rates by 80% in extreme temperature operations. But for Henderson himself, the most important moment came 3 months after the Sicily March. Master Sergeant Michaels approached him in the motor pool, now a proper facility in Palermo, not a dusty compound. Sergeant Henderson, got something for you. Michaels handed him a letter. It was from Henderson's father in Nebraska. Son, your mother showed me the article in Stars and Stripes about your engine modifications. They quoted some Captain Smith saying you improved Army vehicle reliability by 80% in Sicily. I don't know much about military matters, but I know this. You took what you learned on this farm, making equipment survive harsh conditions through practical modifications, and you applied it where it mattered. That makes me prouder than any medal ever could. The tractors here are still running. So are you. That's what counts. Your father. Henderson folded the letter carefully. Everything okay, Sergeant? Michaels asked. Yes, sir. Henderson looked out at the motor pool. Rows of Jeeps, all with his modifications. All ready for whatever harsh conditions the war demanded. Everything's just fine. The farm boy from Nebraska had brought his father's practical wisdom to modern warfare. He defied regulations, risked court-martial, and endured mockery. All because he understood a fundamental truth that engineers in Ohio couldn't have known. Specifications mean nothing if the machine can't survive the conditions it faces. His modified Jeep, the one that outlasted every vehicle in that July 25th convoy, eventually logged over 1,000 hours of operation. When it was finally retired after the war, engineers preserved its engine in the Army Transportation Museum at Fort Eustis, Virginia. The placard reads, Willys MB engine, modified by Sergeant John Henderson, 1943. First successful adaptation of military vehicle specifications for extreme temperature combat operations. This engine design reduced failure rates by 80% and informed post-war military vehicle engineering standards. But Henderson never thought of himself as an engineer or innovator. Years later, in a 1985 interview for an Army history project, he said, I just built an engine that wouldn't die in the heat. Same thing my father did with tractors in Nebraska. Sometimes survival matters more than following someone else's rules, especially when those rules were written for conditions that don't exist. The interviewer asked, Do you think your farm background gave you an advantage? Henderson smiled. 5,000 acres teaches you real quick. Equipment either works or you lose the crop. There's no room for, well, the manual says it should work. Reality doesn't care about manuals. Neither does a Sicilian summer. I just applied reality to military engineering. Turns out, reality wins every time. That simple philosophy, reality over regulations, function over specifications, survival over theory, saved countless lives during World War II. Every vehicle that didn't break down in critical moments, every convoy that reached its destination, every soldier who didn't have to walk because his Jeep failed. They all owed something to a Nebraska farm boy who refused to accept that engines had to die every 72 hours. And if these forgotten stories of ingenuity and courage resonate with you, subscribe to make sure you never miss another piece of history that challenges everything you thought you knew. Because Henderson's story isn't just about engines. It's about having the wisdom to question expert consensus when reality proves the experts wrong, and the courage to act on that wisdom even when authority insists you're mistaken. The farm boy's engine kept running long after the war ended. So did his lesson. Sometimes the people closest to the problem see solutions the experts miss. Sometimes a 5,000-acre farm in Nebraska teaches better engineering than a factory in Ohio. And sometimes, the greatest innovations come not from rejecting knowledge, but from understanding when knowledge needs to adapt to reality. Henderson returned to Nebraska after the war. He took over his father's farm. And there, on 5,000 acres of harsh winters and brutal summers, he continued the work he'd started in Sicily, making machines survive conditions that theoretically should kill them. The tractors still run. The trucks still haul. The equipment still works. Reality still wins. Henderson died in 2003 at age 81. His obituary in the Lincoln Journal-Star mentioned his farming career, his family, and his military service. It did not mention the 15,000 vehicles he helped keep running, or the countless lives saved by engines that didn't die at exactly the wrong moment. But in the archives of Army engineering, his name appears in dozens of technical reports. His modifications informed post-war vehicle design. His philosophy, optimized for real conditions, not theoretical specifications, became standard doctrine for military engineering in extreme environments. The farm boy who was mocked for his abortion of an engine had the last laugh. His design outlasted not just every vehicle in that July 25th convoy, but every criticism, every doubt, and every regulation that said it couldn't be done. Because in the end, reality doesn't care about mockery. It only cares about what works. And Henderson's engine worked.